everyone to the brand new episode of the Code Drop. And this is our data structure series. And here we're going to see what data structures are and how to implement them. So this is our second video, and in this video we're going to see what stacks are and how to implement them in C programming language. So first of all, let's start with what stack is basically. So stack is an abstract data type with a predefined capacity. It's a simple data structure that allows adding and removing elements from the top. So every time an element is added, it goes on top of the stack, and every time an element is removed, it goes out from top of the stack itself. So it's just like a pile of books where you can add a book only on top and remove a book only from top until and unless you want to break the pile and remove everything else. Now data in stack are placed or removed in a principle of LIFO or last in first out. So the element which goes last in is the element which comes out first. So the element we push in the array at last will be the first element to be popped out of the stack. So this was this introduction, and now let's see how to implement a stack using C programming language right here in an example program. So first of all, I'm going to include stdio.h right here, and then I'm going to say int main. So before we start working on our int main function, we need to establish some global variables. So first one is going to be an int size, which will be equal to 5. So you can use any other size. For the example video, I'm just going to go with size 5, and then I'm going to say let's make an integer array, and that array is going to be called stack, and the stack size is also going to be 5. So the size of stack and the size value should be same if you want it to work perfectly. Now again, I'm going to initialize one more variable which will be top. It is basically the position of our element, and that is going to be -1. The reason why we are starting our positions from -1 is because if we are starting to place an element, we are going to place an element in stack of 0 first of all, and if we want to remove something, we'll also be removing from stack of 0 itself if we're doing in the first one. So if you want to insert an element in stack of 0, we need to start our loop from top of -1 so that it becomes top of 0 when we insert an element. This was why we're using top. And now a stack consists of three main functions. First is called push function, and this push function will just pass one variable, one value, which is going to be our parameter, and this is the value which we're going to insert in the array. So what push function does is it basically inserts the values which we feed into the array, or rather stack. And then we have a pop function. What pop function does is it basically pops out the topmost element from the stack. And then at last we have a peek function. So peek function is used to print the element which is on the top of the stack at any given moment. So let's restructure our main function. Let's push two elements. Let's just say it's 5 and 6, and then let's peek first. And to use peek, we're going to use a printf statement, and in printf we're going to say mod d comma, we're going to call our peek function right here. So let's copy it from here and paste it here, and using our pop function is going to be at end so that we know which element is on top, and then we remove the element. And after we do it, let's add one more peek function right here so that we can know that we have removed the correct element. So let's add a slash n right here and right here, and let's add mod d is on top of the stack so that we get the value which is on top of stack. Now you can notice that I've passed parameters in the push function but not in pop and peek function. It's because we want to insert a value using the push function. That's why we need to pass a value to the push function. But we know that we are going to remove the topmost element. It doesn't matter what the element is. So we're going to remove the topmost element when we use a pop function. That's why we don't need a parameter for the pop function. And similarly for the peek function, we're going to print the element which is on top. That's why we again don't need the any parameters, because we'll just call our top variable which we have declared globally to pop or print our topmost value. So we have already set up our main function. Now let's start making our push, pop, and peek functions. So first of all, I'm going to go with push, and I'm passing a parameter. So I'll just say int, let's go with lm for element. And here, first of all, we're going to check if the stack is full or not. So what I'm going to do is I'm going to check if top equals size. Because if top equals size, it means that we have filled all the elements and there is no place left in the stack for any other element to be placed. So if this happens, we're going to say printf slash n stack is full, the element could not be inserted. And that's it for our full part. And else, if the stack is not full, then what I'm going to do is I'm going to say top equals top plus 1. So if our top was -1 initially, it becomes 0. And then we place stack of top equals to, let's say, our lm, the element which we are passing as parameter. So now you can see what I was meaning when I said that we are using -1 as top. Now here we are changing the value of top from -1 to 0, and then we are inserting the element value in stack of top, which in this case is stack of 0. So stack of 0 is the first element which gets our input lm stored in it. So this was the push function. Now let's go for the pop function right here, and I'm going to say int pop function. It is needed in parameters, and then again we're going to check that if the stack is empty. So there's a thing you can remember, that if we are checking, if we have to push an element, you need to check if stack is full or not, and if you are popping an element, you can check if the stack is empty or not. So here I'm going to check if top equals -1. So why doing this is that if top equals -1, that means that we've already removed the bottommost element which was placed on stack of 0. It means that there is no further element to be removed, and that's why we'll printf slash n stack is empty. It's going to be empty, no elements removed. So this part is not required because obviously there weren't any elements. That's why our pop function didn't work. Now again, what I'm doing is I'm going to first declare a variable called data. It will not have any value. It's just going to be a null value or a chunk value, whichever the compiler provides. And then I'm going to say stack of top, sorry, stack of top equals to data. So now we are allocating the dump value or the null value to our stack of top, and then I'm going to say top equals top -1, and let's save it right here. So this was our pop function. Now let's make our peak function. So peak function is the easiest of them all because we just want to return whatever is on the top. So we're just going to say return stack of top, and that's it for our peak function. So we have set up our main function and we've made all of our push, pop, and peak functions. So let's just compile this program and see what the output is. Okay, so it says that 6 is on top of stock and 5 is on top of stack. Now we can see that the peak function is working, but we don't know if the element was inserted and removed or not. So we'll just add one more printf statements in both uh, pop and print function. And in the pop function, we'll say element at top was removed, and let's add a slash in for this. And again, in our push function, we'll say printf, and again I'm going to go slash in, and mod d was added to the stack, and we're going to say that lm was added to the stack right here. So whatever we pass in the parameter, it gets stacked up. So let's recompile our program again and let's see the output. So 5 was added to stack, 6 was added to stack, 6 is on top of stack, an element at top was removed, and 5 is on top of the stack. So our program is working nice and cool. So what else can we do? Let's make a choice-based decision for our users. So what I'm doing is I'm going to make an integer choice, and then going to printf what, let's give a slash in, what do you want to do, one for push, two, and let's just remove this, and two for pop, slash in, three for peak, and actually let's add another four for exit. So this is where we take choices from the user, and I'm going to run this whole loop in a while one so that it gets run infinite times. Let's place it right here. Let's add a tabbed space to maintain the consistency with our indentation, and then we'll take the input from user. Let's take input for mod D and choice. So if choice equals 1, then we'll make one more variable val, and we're going to ask the user what is the element we want to insert. So printf slash n, enter the element to be inserted in the stack, right here, and let's give a colon right here, and then I'm going to take input from the user, which will be for our value val. And once I take our input, I'm going to say again that pass push function with my parameter val. So this is for our push function. Let's remove push from here, and then let's just copy this whole thing. Actually, we don't need to copy that because others are going to be easy. So int choice equals 2. Let's make it else if choice equals 2. Then what I'm going to do is I'm going to say we don't need an integer here. Then we're just going to remove, we're just going to call our pop function, and else if choice equals 3, then we're going to print the top element. So let's cut it from here and paste it here, our printf statement for printing the element on top, and let's remove our pop and printf function right now. At end of it, I'm just going to say return 0 at the end of main function, and that's about it. That's the program. Let's compile it once and let's see it in action. And this is the output we're getting. So let's just push an element first. Let's push in 5 element here. 5 was added to stack, and then let's again push 7. So 7 was added to stack. Now let's remove an element at top was removed. So let's peek first. 5 is on top, so 5 was actually on top before. Let's just push one more element. Let's again push 8, and let's peek. So peek is for 3. So we get 8 is on top of the stack. So this is our working program for stack using arrays. And let's just exit this code. Okay, we didn't write anything for exit. So we're just not going to compile the program again, but let me just say that else exit 0. And if you do that, you will exit the program. Let's just make it else if choice equals 0, because if we just keep it as else, then if a user enters anything other than 1 2 3 4, it's going to exit the program. So let's put else if choice equals 4, exit the program. So this is how you implement stack in C programming language. And that's it for today, guys. If you like the video, hit the thumbs up button right there, and if you love the video, subscribe to the channel. I'll see you on the next episode of the Code Drop. Bye for now.